Hi, math nerds. Sorry for the bad voice. This is a lesson on Introduction to Geometry, and my expectation is that you've already read the booklet and understand the terminology, memorize the terminology, and are looking for some more clarification, some more practice. So to go through this, I want you to listen carefully and try and get as much out of it as you can. This diagram is provided. I'm going to start out of order. I'm going to start, first of all, doing the acute angles. The acute angles are the angles that are less than 90. So I see on the diagram 3 acute angles that we're going to trace. I see an acute angle there, angle CTB. You can also say it backwards, angle BTC. No way is right or wrong. I see angle ETD and also angle DTA. 3 of them in total. So angle BTC, of course you could also say it as angle CTB, angle ETD, and angle DTA. Any one of those angles can be said backwards or forwards. The most important part is that the letter in the middle, which is called the vertex, where the 2 lines meet. Okay, now we're going to do the obtuse angles. And the obtuse angles are the angles that are greater than 90, but less than 180. So here's one. From C to T, T to A, that angle in there is an obtuse angle. You could also see angle BTD. That angle there is also obtuse. Then if you're thinking a little bit differently, perhaps this one, angle CTE. Those 2 angles put together. That's also obtuse. So for the description, I could write angle CTA or ATC, angle BTD, or vice versa, angle DTB, and I can also write the 2 angles that are side by side, angle CTE, angle CTE, which is 2 angles adjacent added together. Now let's talk about the right angles. A right angle is made when 2 lines that are perpendicular meet. A right angle is marked by its symbol, like the one in your diagram, at the vertex of T, and that angle looks like a little box, same on both sides. So the right angle in this diagram could be either angle ETA, you could say it as ATE if you wanted to. And there's also another right angle, angle BTE, or angle ETB. Let's talk about the reflex angles now. Reflex angles are, by definition, angles that are greater than 180, but less than a complete revolution of 360. Here's an example. If you started with line BT and the second line, and you rotated it around and ended up here at TC, you would have made a large angle, in fact almost a complete angle. That angle will be a reflex angle, greater than 180, but less than 360. to describe a reflex angle, that angle that I drew and traced in pink is angle BTC. But to show that I mean the outside angle, BTC, and not the acute angle on the other side, I must write the word reflex and then the symbol for angle BTC. And that describes that I'm talking about the angle, not acute, but on the other side, or in this case, a reflex. I'll show you another one. There's many, many on this diagram. There's no limit to what you could choose. Say you did line BT swung around to TE, that would actually be 270 degrees, a reflex angle. To show it by description, you would describe it as angle, with the word reflex in front, reflex angle, BTE, or angle ETB. The word reflex in the front describes that it's the outside angle, the one between greater than 360 or greater than 180 but less than 360. Now let's talk about complementary and supplementary angles. Complementary angles, by definition, are two angles, or maybe more, that add to give you 90 degrees. There's a 90-degree angle, but it can also be made from two adjacent angles that are side by side, which adjacent means, that add to give you 90. So for example, angle ETD together with angle DTA, those two angles, here and here, would add to give you 90. They are complementary. I want you to think C, complementary, think corner. Help you remember that. Now, supplementary angles, you're going to use this so many times. Between now and we finish geometry, you have to get it straight in your head. Supplementary angles are angles that add to give you 180. They're going to be straight. There's all kinds of ways to do this. There's a straight line. It's cut into two angles. So I have a small angle here, acute, and an obtuse angle there. If I knew the measure of one of the angles, I could find the other one by subtracting it from 180. Using a letter description, I could say angle DTA and angle CTA. They are supplementary. There's all kinds of angles here. Say I took this line. I could do this angle. So I could do this one and this one. So for example, you could say angle EBT and angle ETA. Those angles add to give you 180. Think S, think straight line. S is straight, complementary is a straight line, and complementary is a corner, and supplementary is a straight line. Straight means 180, and complementary is, of course, a 90. So the real goal for you is to be able to find missing measurements on a diagram. When you're given one angle, find another. So one term that comes up quite a bit, not listed here, is the word adjacent. So adjacent angles are angles that share a common side. For example, that angle DTA and angle ETD share a common side and a common vertex, side DT. Last but not least on this diagram, I want you to be able to be quite competent at doing vertically opposite angles. Whenever you have two lines that intersect at a common point, essentially what you have is a pair of scissors. And I know that's silly, but it works. So when you have vertically opposite angles, that means the opposite angles are always equal. And you could tell by size. The acute angles on each side are equal, and the obtuse angles are also equal. So in your vertically opposite angles, the angles that are not touching, i.e. not side by side, but across from each other, they're what we call vertically opposite. So in our diagram, angle BTC is vertically opposite to and equal to angle DTA. The acute and the acute are equal. Also, angle CTA, which is the obtuse angle, is vertically opposite to angle BTD. And those angles can be shown in the diagram. So this large angle here, it's obviously greater than 90, is equal to the angle across from it. So with your scissors, the opposite angles are always equal. Okay, now I'm going to give you the answers to the unknown angles at the bottom. And as I go through these, I'm going to explain many ways to do it, because a lot of people see things differently in geometry, so it's good to be able to recognize different perspectives. So it's going to sound like overkill, but suck it up. For example, for angle Y, I would look at that diagram and I would see that 60 and Y are two angles on a straight line that are side by side, and therefore those two angles are supplementary. So if the smaller angle on the top is 60, then Y has to equal 120 degrees. On the other side of that diagram, you can do the same thing. You can put another line, or you can even draw a different line. If you see that green line as a straight line, therefore all the angles in that diagram and on that line I have to add to give you 180. Then 60 plus x plus x. Now x and x are equal, they have the same letter. Then 180 minus 60 is going to give you 120. And 120 divided by 2 gives you a measurement of 60 degrees for x and 60 degrees for the second x. That being said, I want you to watch something else. So look at this perspective as well. If I draw a set of scissors, then I have vertically opposite angles. And if I find angle Y to be 120, then the two angle x's should also equal 120, and they do. So that's very similar to the diagram for B. If we look at the diagram for B, we have two straight lines that intersect at a common point. So to find the missing angles in this diagram, you just need to use some basic math skills. So 58 from 180 would give you Z of 122 degrees. You could do 58 and x together also add to give you 180. Or perhaps you would see angle Z and angle X as being vertically opposite, the scissors, so to speak, so they're equal. Perhaps you see angle Y and angle 58 as opposite angles, so they're of course going to be equal. One thing you should note is that angle Y plus Z plus X plus the 58 make one complete circle. Therefore, the angles you have for all those should add to give you 360 degrees. And they do. 122, 122, 58, and 58. Adds to give you 360. So you know that you've done something right with your math. 122 in here. Question C. Perhaps you'd see this diagram. There's a 90-degree angle in there, which means that angle's a right angle. And the angle X and the angle 40 are adjacent side-by-side angles. Therefore, if the angle marked 40 is known, then angle X must be the complementary angle is 50 degrees. And then once you know angle X, you should recognize that X and Y are on a straight line, and that straight line has been bisected, not a good word, but cut into two angles that are not equal. So then if you took the total of 180, subtracted 50, you would get 130 for Y. So Y is an obtuse angle, which makes sense from the way that it looks. For diagram D, maybe you see scissors. If you see scissors, then perhaps you could see that the angle that's obtuse, 120, is also going to be obtuse on the other side. And one part of the angle is known, even though it's not given directly. With a right angle, it's 90 degrees. So if the angle is 90, then angle X must add to give you the 120. So that means X would be 30 degrees. You want to double check. You could do a whole bunch of things. You could maybe do that angle there of 60 first by doing 120 on a straight line, so that angle is 60. Maybe do vertically opposite over here to get a 60. Then you do another straight line in the bottom. I'll add to give you 180. There's all kinds of ways to do these diagrams. And I can tell you that the most likely chances of success in geometry is this very important hint. And that is, you should not be afraid to find angles you're not asked to find to get towards the angles that you are asked to find. So don't be afraid of doing a little extra work. It'll often get you on the path you need to be on to get to where you have to go. Now in this diagram I see a triangle. I see three lines that meet. There's three corners, three vertexes, pronounced vertices. This is a special triangle because it has indicators of two of the lengths of the sides being equal. That makes that triangle what we call isosceles. Learn how to spell that word, please. isosceles. In an isosceles triangle, there will always be two equal lengths, and there will always be two equal angles. To find which two angles are equal, if you know your sides are marked equal, then draw a line across to the angle from each of your marked sides. And those are your equal angles, and they are called the base angles. The third angle in an isosceles triangle, the two that aren't equal, the third one, that's called a vertex angle. It can be right, it can be obtuse, it can be acute. But what you have to know about all triangles is the three angles always add to give you 180 degrees. So if I have a 30 in one corner, and I have another 30 in the other corner, that makes 60. So x must be 120 to add to your 180. To solve for y, I have a straight line, and the acute angle is 30, so the angle beside it, the obtuse angle, would have to be the supplement to 30, so it would be equal to 150 degrees. In diagram F, I also see a triangle, so I can trace that in my mind, and that'll help me because I know that 3 angles have to add to give you 180. So 68 and 41, add those together, subtract from 180, 109. Angle A is 71 degrees. If you're also looking at these two lines intersecting, then it would scream at you, I hope, that angle B is also 71 degrees because they are vertically opposite. They're not side by side, they're across from each other. Now angle A and angle C are on a straight line, therefore they're supplementary. So 180 minus 71 would make angle C 109. And that angle does appear to be obtuse. And I'll always try my best in these diagrams not to give you an angle that's wildly off. It may sometimes not be terrifically to scale, but it shouldn't be horrible. So, for example, applying that, I see a triangle here in diagram G. So I know they're going to add to give me 180. I see a straight line. Angle 120 and angle Y are on a straight line together, which makes them supplementary, which makes it 180. So therefore angle Y is going to be equal to 60. Same thing on the other side. If the obtuse angle of 140 is adjacent to angle X, they must add to give you 180. So X will also equal 40 degrees. They're not equal, but they do add to give you the supplement. So 60 and 40 is 100, therefore angle Z would be an 80. And they all add to give you 180. We'll note that all 3 angles in that triangle are different. Just an observation. Now in the diagram for H, you have to recognize an isosceles triangle by the fact that you have 2 equal lengths. Now students are often unsuccessful deciding which 2 angles are equal, but you need to get successful at that. So that angle across from the line and this angle are equal. I've got a 50 and a 50, which is 100. That would require then X, the vertex angle, to be 80. Now X and Y are equal because they are vertically opposite, like the scissors. So if Y is 80 and a angle marked 40 is 120, then Z would equal 60. For diagram I see a triangle, and a nice isosceles triangle actually, and I also see a right angle. So if that angle in the corner is a right angle, then angle X would have to be the complement to 50, which makes it 40 degrees. And then if that's 40, then this angle and this angle are equal. So this angle down here, that you're not asked to find, but you still have to find, is also 40. And angle Y will be 80. No, it won't. Angle Y would have to be 100, because 40 and 40 is 80. And last but not least, questions that always give students trouble who don't read their booklet. And you know who you are. Alright, here we go. Triangle A has 3 different lengths. So I'm going to classify them by its sides. I'm going to call that scalene, because all the sides are different. If I'm going to classify it by its angles, the biggest angle is 80, which is acute. So it becomes by its angles, an acute angled triangle. Part B, I see 2 equal sides. So classifying it by its sides, it's isosceles. Classifying it by its angle, the biggest angle is a 90, so it could also be called a right angle triangle. Either one of those are correct, but depending on what I ask for, be careful. For C, I see an isosceles triangle again, because there's 2 equal marks. And of course there's also 2 equal base angles, 40 and 40. Therefore it must be an isosceles if you're describing the lengths. But if you're describing the angle of this triangle, the biggest angle is actually greater than 90. So this will be classified as an obtuse angle triangle, because the angle is greater than 90. Oh, that's messy. An obtuse angle triangle. And lastly, special case. All the sides are equal, and that's called an equilateral triangle. If all the sides are equal, then all the angles are equal. So if you take 180 and divide it by 3, that gives you 60-degree angles in all of your corners. And because the largest angle is less than 90, this triangle is also classified as acute angled. So watch your terminology and study your definitions of different types of triangles, and you should be fine with this first week of geometry. Don't forget there's practice in your booklet with answers, and of course you can read the theory a couple times to be a genius. Good luck.